All right, welcome back to Elements of Calc 2 here. So today we are going to be talking about how to find minimums and maximums. All right. And remembering Calc 1, right? Let me go ahead and bring up a screen here so I can write some stuff down. Okay. Remembering Calc 1, we had to do a second derivative test. We didn't have to, but you took the first derivative, you set it equal to 0, you solved for x, you plugged it back into the original function, you said, what is f of x? You got a y, and that was your minimum or maximum, okay? And then we could do a second derivative test, right? And if your second derivative test was positive, right, that means you were concave up. That means you did something like this, concave up, so you knew it was a minimum. And if your second derivative test was negative, right, that means you had something like that, concave down, okay? So that was a maximum, okay? In 3 dimensions, it's really hard to tell because you got things going this way, that way, and the other ways. So we have a special way of figuring this out, okay? So when you have to find a derivative in 3 dimensions, or find a minimum or maximum in 3 dimensions, you're going to go ahead. Here's the procedure. You're going to figure out, we use primes. We want to do this. Okay, so step 1 is you're going to find the partial of x, set it equal to 0, partial of y, set it equal to 0. You're going to have a system of equations here. So you're going to solve and you get your xy pairs. There might be more than one. That's okay. Right? Second thing you're going to do is you're going to generate your f of x and f of y and f of xy. All right. Now, what we have to do here is we have to take what is f of x times f of y minus f of xy, because remember, yx and xy are equal, squared, and we have to, well, that's going to be what they call a determinant. Okay, abbreviated D. Okay, now you're not responsible for memorizing this formula. Okay, I got to look it up every time I do it too. The only time I memorized it was in the middle of Calc 3, which is when the engineering students take this. If this value D is greater than 0, okay, and fxx is greater than 0, then we have a minimum. Otherwise, right, we have a, oh no, sorry, we have, see, I don't even know. I have to do I think you have a minimum. I think here's a maximum. Okay. If your D is less than 0, we have what they call a saddle point. It doesn't matter what your values are. Okay. Saddle point means you've got like some kind of a function going in this in like your x direction, and you've got a thing going like that in your y direction. Okay, so we have a something like that. So you could fit on a saddle. Okay, a terrible. The PowerPoints have a much better drawing than I do. Okay, but you have in one direction it's kind of going up. Okay, in the other direction it's a maximum. We call it a saddle point. We don't really call it a min or a maximum. We just call it a saddle point and say, great, have a nice day. Okay. If your discriminant equals 0, or determinant rather equals 0, then we don't know what the heck is going on. Okay. You have to use other methods. Okay. So you're kind of stuck. Now, your book does not go into like really screwy functions. It shows you a couple of these. It shows you one of these, but the example they use is pretty easy to like figure out like what's going on. But it's still, you're still not going to be you're not going to have all the answers at your fingertips. Now, are you going to be responsible for doing this? Like, no. I mean, yes, but you're not going to be responsible for memorizing it. So, on your quizzes, when there are min-max problems, I will put this formula in question 5. Question 5 will be a true false question. You have access to it. The answer is always going to be true. Okay, so it's not going to be worth very many points. It'll be like 0.01 points, but it lets me put formulas inside of the quiz without you having to reference website somewhere else. Do you get this table? You sure do. Okay, so you'll get this table. You know, they do something like this. You'll see it in your book. It's very nice. Okay, but I'll put the same table in your quiz 5, your question number 5. Okay, so that you have access to it. So you're not memorizing this stuff. All right, I just want you to be able to figure out, like, what are we doing? But the problems are that you know, in one dimension it's not so bad, but in 2 dimensions, 3 dimensions, it gets pretty awful. Okay, so understand that figuring out mins and maxes, that's easier said than done. All right, so our calculus is great for 1 dimension, works for 2 dimensions, but it starts getting a lot harder. Okay, so let's go through the examples here and we'll see about that. I set my alarm so that I would keep this to my about 30 minutes. Okay, so let's just go ahead and take a look, and then we'll go ahead and do that. All right, so let's get down a little bit. Start here. What are we doing? We have, what am I? Work sections. Okay. So here we go. Problem number 1. Okay. So they start off with a kind of a nice function. Okay. So we have f of x, y is equal to x, y plus y minus 14x. All right. So what did we say to do? Right, we have to find minimums and maximums. So our fx, right, take the partial derivative with respect to x, we get y minus 14. Okay. For partial derivative of respect to y, we're going to end up, right, we're taking the derivative with respect to y here. So we're going to get an x, okay, and minus, or plus 1 rather. Okay, and that looks like it's good. So with x, right, we have constant times x, so we get the constant. This was a 0 term, and then minus 14x. Derivative is 14. Fy, right, constant. So just the x plus 1. This is a 0, so as far as y goes. Okay, so we have to go ahead to solve this. So we set it equal to 0. Okay, so this is steps 1 and 2. So y is equal to 14. And x is equal to negative 1. All right, that's our critical point. All right, so if we have points that we have to plug into our determinant, all right, our d, then these are the points we're going to be picking in. Okay, now we also have to know, what is f of xx? Well, let's take this x derivative with respect to these two. They're both constants. 0. How about fyy? They're both constants. That's 0. Okay. How about f of xy? So we have to take this derivative, right? We did fy, right? Fy is equal to x plus 1. Now we have to take this derivative with respect to x. Get 1. All right. Same thing over here. If we have to take this derivative with respect to y, we get 1. All right. So what is this going to be? Fxx times fyy minus f of xy squared. We get 0 times 0 minus 1 squared is equal to negative 1. My determinant here is less than 0. Okay. So now we're going to go back to our handy dandy little chart here. We have our determinant is less than 0. That means this is a saddle point. Okay, I can't draw this for us. Okay, so my point, negative 1, 14. That's the x value, 14, that's the y value. This would be a saddle point. That would mean, like, wherever this is, like, the x value will be going up, the y value will be going down. all right? Or vice versa, the y values are going up and the x values are going down. I don't know. Okay, we have to draw it in order to figure that out. But there we or plug in some more points, which we're not going to do. Okay, but that's a saddle point. So find the local maxima for the choice below. There are no local maxima. So we look for maximums, there aren't any. All right. Really? Come on. Let's see here. Check it. Okay, no. Check answer. Great. Looking for minimums. There wasn't a minimum. It's a saddle point. So there are no minimums. Check answer. Great. Okay. Do we have a saddle point? There is a saddle point. Where is it? Okay. And we said that that was going to be at -1, 14. There we go. Check that, and we should be good. Fantastic. All right, let's do a similar question here. All right. So next one, set it up. We're going to do exactly the same thing. Exactly the same procedure here. All right. So here is our function. We have f of x, y. It's equal to 2x squared plus 3xy minus 7x plus, oh no, minus. Let's erase properly here. Minus 11y, right? Great. What is my partial with respect to x? Well, that's 4x plus 3y minus 7. What is my partial with respect to y? Well, that's a 0. We have 3x, okay? Partial with respect to y, okay? Is this? All right. 3x minus, looks like 11. Oh, there was a 4x. I'm sorry. I wrote down the wrong problem. This was 2x squared plus 3xy plus 4y squared minus 11y. Okay, these are usually pretty similar to the problems they wanted. So the x and the y should come out to be something reasonable. So this was a constant for y, so I didn't need it. But for x, right, taking the partial with y, we're going to have a 3x plus 8y, right, minus 11. All right. Now we need fxx. So take this derivative with respect to y, with respect to x, just 4. Take this derivative with respect to y. This is 8. And then we have to crisscross them, right? X, y. So we're going to go here and say, okay, well, we have derivative of x. Now we have to take derivative of y. 0, 3, and just to double check it, right? Y, x. So take this derivative with respect to x, and we end up with a 3. You didn't have to do that. I'm just doing that as a check. All right. So we're there. All right. We have to now solve, right? We have 4x plus 3y minus 7 equal to 0. So we're on step 2, where we're setting first derivatives equal to 0. Okay. So we have 3x plus 8y minus 11 equals 0. So this is 4x plus 3y is equal to 7. 3x plus 8y equals 11. We have 2 equations, 2 unknowns. You guys know how to solve this? Do you remember? All right. So let's multiply this by 8. Let's multiply this by -3. Okay. Once you've done it like 2 or 3 times, you'll remember. Okay, all the pain that was intermediate algebra, and you'll say, "Oh yeah, I remember how to do this." Okay. So we have 32x plus 24y is equal to 56. We have -9x minus 24y equals negative 33. I almost always do elimination if it's linear. If there's like powers in here, we have to do substitution. So just to let you know that that's what's coming up. All right, this cancels. 56 minus 33, what is that? That's 23. And then 32 minus 9. And here we have 12 minus 9 is 3. Hey, look at that. 23x equals 23. Okay, go figure. X equals 1. You can use this x equals 1 in either of the representations we have from before. Okay, so let's go ahead and say we have 4 times 1 plus 3y minus 7 equals 0. Okay, so either one of these is just fine. Okay, what if I plugged it into this one? That's fine, we don't care. Okay, so either one of these would have been just fine. Okay, we have 4 plus 3y minus 7 equals 0. 4 minus 7, that's 3, so 3y minus 3 equals 0. 3y equals 3, or y equals 1. Great, we have x equals 1 and y equals 1. That's our critical point. Do I know if it's a max or min yet? No. Do I know if it's a saddle point yet? No. But I do know whatever happens is going to happen at this point. Okay. So now we have to go back and say, well, we have f of xx times f of yy minus f of xy squared. Okay, what is f of xx? Let's go all the way back up here. That's 4. Okay, f of yy, what's that? That's 8. Minus, what is the cross, right? When we crisscrossed them, what's that? So that was 3. Okay, so minus 3 squared. What is this? Well, this is 32 minus 9. This is bigger than 0, right? If I have $32 in my bank account, it's not that inaccurate, and I pay something that's $9, I still have a positive bank account. So life is good. All right, so now we know that my determinant is greater than 0. F of xx is also greater than 0 because it's 4. Okay, so 4 is bigger than 0. Determinant 32 minus 9, which is what, 23, is greater than 0. So we can go to our chart, right, and say, well, if my determinant is greater than 0, all right, then we're on the first little chart thing here, right? This was d was greater than 0. Then we have fxx and fxx. If fxx was greater than 0, then we have a min. Otherwise, we have a max. All right. Double check those for us when I write those down. Okay, so we have a minimum. Where's our minimum? Well, it's at the 0.11. All right. And again, asking me to like graph this thing out, like best of luck. All right. That goes for you guys too. Best of luck graphing this out. Okay, but that's my minimum. Let's see, kind of looks like a shifted notice that we have like x squareds and y squareds. We have a z equals. So we have a z equals a 2x squared plus 3xy plus 4y squared minus 11x minus 11y. This guy here, we have ellipse, but it's slanted, it's rotated, okay, because that's what this term does, and then it's shifted. Okay, so we have some kind of a, we would have some kind of a parabolic ellipse, but it's like moved over here somewhere. Okay, that's using the algebra that we know, right? That's what these shifts do, because we'd have to complete the square. Remember that? We're not doing that. Okay, but that's what we'd have. So we have some kind of a minimum thing because it's like a parabola that is an ellipse in its cross section. Okay, so what are the maximums? No maximums. Okay, great. What are the minimums? We do have a minimum, right? And that was at 1, 1, right? And then I don't know why I'd ask you this, but once you said it was a minimum, it's like, well, actually we could have minimums and maximums, minimums, or saddle points. Like we don't have to have just one. Okay, but there are no saddle points. All right, because we only got one solution. All right, let's see how much time do we have here. Should I chance another one or make it a different thing? We're good. Okay. Maybe something that's a little bit harder. Let's do this one. Okay, I don't think this is going to be that terrible, but I know these are long problems. Again, just by looking at it, right, we have positive. There's different amounts here. Did I actually get like a different one here? Question 4. Yeah, sure did. All right, so maybe they throw us a curveball on this one. Okay, but I think this is an ellipsoid that is translated. It's a little bit over in the x direction, a little bit on this side, or a little bit back for the y direction, and we'll see. Okay. Step 1, fx, right? Taking the partial derivative with respect to x. So that's going to be 4x plus 3y minus 2 fy. That's going to be 3x plus 8y plus 10. This is the same question we had before. Oh, well, let's finish it. Okay, you need some practice solving equations and unknowns and stuff, so let's just go through it. All right, what is my partial? Again, with x. So we're taking this function here and taking the partial with respect to x. So that's just 4. Okay, how about here? Taking this value here, we're saying, okay, that's 8. Partial with respect to y. Okay, this is f of xy. So we're taking, what's the derivative? This is 3. Is this the same problem we just did? I think it is. Yeah. I mean, the numbers are a little different, but it's like this is like the same problem. Okay. So that was step 1. Step 2 is we're going to set these guys equal to 0. So we have 4x plus 3y minus 2 equals 0, and 3x plus 8y plus 10 equals 0. This is too similar. So this is 4x plus 3y is equal to 2. 3x plus 8y equals negative 10. I'm going to stop us here because what we're going to do is multiply this by 3. I'm sorry, I'm going to multiply this by 8, this by negative 3, and go through the same section we just did. Thanks, guys. You guys, they gave you the question that ranged from A to A. All right. All right, this one's interesting. Okay, we'll say on the one I just did, the remainder is left as an exercise for the reader. Okay, going through solving these two equations, 2 unknowns, not going to be that bad. And then figuring out the determinant and deciding it's going to be a very similar problem than what we just did. This one, however, okay, 1 minus x to the 4th minus y to the 4th. This looks a little interesting because we do have a critical point, but yeah, we're going to get in determinant form here. Let's go ahead and can I do another one? No. Okay, they have exactly one of these problems. Okay. I don't blame them. They're not easy to find. Okay, so here we go. fx, right, partial. So we're going to say this is 4x cubed fy. That's going to be 4y cubed. Okay, taking partials of each. Now, fxx, taking this derivative again, is going to be 12x squared. Fyy, that's going to be 12y squared. Okay. F of xy, we're going to take this derivative with respect to y. 0. All right. So setting step 2, fx equals 4x cubed, set it equal to 0 and solve for x. Fy is equal to 4y cubed, set it equal to 0, solve for y. All right. I hope that that's not going too fast for anybody, I hope. Okay. Now we need fxx, fy, y minus fxy squared. Okay. So we have 12x squared times 12y squared minus 0 squared. Like, uh-oh, we've got some variables in here, right? We've got 144 xy squared minus 0. What do I pick for my x and y? What do we find in the values up here? We found x is 0 and y is 0. So we're going to say x is 0 and y is 0. So 0 times 0, 0 minus 0 equals 0. This is where my determinant is equal to 0. So we don't know. We have no idea what's going on. Okay, in my chart, this gives you we can't tell. Okay, so we're going to kind of apply some geometric intuition here, right? We have 1 minus x to the 4th minus y to the 4th. All right. If I plug anything in for x or I plug anything in for y, 1 minus that value, right? Because these are going to be positive, doesn't matter. 1 minus that value is going to be a smaller number. Okay, so pick any number you want for x, pick any number you want for y. Okay, so we could say x equals 1, y equals 0. We have 1 minus 1 equals 0. Notice if we picked x equals 0 and y equals 0, our critical point, we have 1 minus 0 minus 0, which is 1. This number is bigger than 0. Pick any other number you want. Pick y equals 2, right? Pick x equals 1, y equals 2. 1 minus 1 raised to the 4th minus 2 to the 4th, that's 16. 1 minus 1 minus 16 is equal to negative 16. I would rather have $1 in my bank account than owe somebody $16. Okay, this one's bigger. Positive numbers are bigger than negative numbers. Okay, so we do have a critical point at 0, 0, because that's what we found. All right, we checked that the determinant was actually equal to 0. Okay, you're going to give us more. The value of this function, plug in 0, we get 1. Okay, hooray, dopamine. Okay, the derivative, xxx, right? This was equal to 0, right? At the critical point. If I plug in x equals 0, fxx is equal to 0. So, oh, how do you know it's a relative minimum? We don't know it's a relative minimum. Oh, it's relative maximum. Oh, okay, I can read. Relative maximum, because this one has to be greater than anything else. Okay, this one. Value x, 1 minus x to the 4th minus y to the 4th must be less than any 0 or less than 1 for anything you plug in for xy. Okay, you plug in anything, we're going to get something smaller than 1. Okay. All right. And I think that's all they wanted us to do with this one. All right. So let's see, what are we looking at here? 5 minutes. All right, let's see. We have squareds. I think we could do it. Let's try it. 5 minutes. Okay. we have this R function, okay? Total revenue, hundreds of dollars from the sale of X spas and Y solar heaters. Okay, it's approximated by. So we have, this is 12 plus 160X plus 115 Y's minus 5X squared minus 3Y squared minus 5XY. This is X is equal to number of spas sold, Y equals number of heaters sold. Okay, it's a good idea to note your variables as you're doing this. Okay, so our X, right, partial derivative with respect to X, we get 160. This one is 0 minus 10X minus 5Y. Okay, our Y, 0, 0. We get 115 because it's partial with respect to Y minus 6Y minus 5X, partial with respect to Y. Right? Our XX. Okay. So take this derivative here, take this function here and take its derivative. Negative 10. R, Y, Y. Take this function here, just treat it as its own function, and take the derivative with respect to Y. Negative 6. Okay, 0 and 0 because it's with respect to Y, and these things are considered constants as far as Y is concerned. Okay, R of XY, which is equal to R of YX. Okay, so if I take my derivative, right, RY, take the derivative with respect to X at negative 5. Same thing over here. If we take X, R of X, and then take the derivative with respect to Y, we get negative 5. Okay, so my determinant, this is equal to negative 10. Come on, really? Negative 10 times negative 6 minus negative 5 squared. We get 60 minus 25, and that's equal to, I think, 35. Okay, it's greater than 0. All right, it's greater than 0. And so our determinant is greater than 0. We have to do some work now. All right, we have 2 points. We have 2 equations here. We have negative 10x minus 5y minus 5y plus 160 equals 0. Right. That's this one. We have negative 5x minus 6y. Minus 115 is equal to 0. Let's massage this a little bit. So we've got negative 10x minus 5y is equal to negative 160. Here we have negative 5x minus 6y is equal to negative 115. Okay, this one is pretty simple to get as a, if I can cast out a 5 here, let's multiply by negative 1/5. All right, 10 over 5, that's 2. 5 over 5, that's 1. I'm changing all the signs. 160 over 5. What is that going to be? 30. That's 15, 10, it's 32. Okay. 115, I don't think 115, 5, 6, 7, not divisible by 6. So let's leave this one alone and just say 5x plus 6y is equal to 115. Okay. So we have to solve this equation. X plus y is equal to 32. I want to do elimination. How about we multiply this one by negative 6? Okay, because we're going to be able to get rid of that. Okay, 5x plus 6y is equal to 115. We have negative 12x. Okay, minus 6y is equal to, what's 32 times 6? That's going to be 180 plus 12, that's 192, minus 192. Be careful with your signs. Add 12 minus 5, negative 7x. This one's 0, right? 0. And then we have 192 and 115. That's a 777. Negative, because that's bigger. X is equal to, right? 11. Oh, sorry about that. If you were sleeping to this, I'm sorry I woke you up. Okay. So put back into any of the equations you want. I would suggest the smaller ones. So we have 2 times 11 plus y equals 32. Putting it back into this equation. Okay. 22 plus y is equal to 32. Y is equal to 10. So we have x equals 11, y equals 10. All right. That's my critical point. What did we find for my determinant? We found that it was always positive. Okay, so we go back and look. All right, we go back up to that chart and we say, well, d is greater than 0. F of xx, what was f of xx? R of xx was negative, right? Was negative 10. So when the determinant is greater than 0 and f of xx, this is less than 0, we have I think we have a maximum value here. All right, we have a maximum value. Does that make sense in the context of the problem? Total revenue, find a total number that should be sold to produce a maximum revenue. Excellent. So we have our maximum. Okay. So again, if you're like, how did you remember that? Like, I've got it written off on the side. All right, that's what I did. So you're going to have this. So if you're doing your homework and you're consistently looking this up on the table, you've made a little note and you just keep consulting it, that is going to be exactly the same situation as you're going to have on your quiz. So R of xx, let's go ahead and finish this guy up here. R of xx, this was negative 10. All right. R of yy, this was negative 6. And I think R of xy, this was negative 5. Let me go ahead and double check. Yep, negative 5. Okay. So check. Okay. And selling, well, X, right? This is why you write it down. Is that you would know that X was equal to spas, and that was going to give us 11 spas. And 10 solar heaters was going to give us our maximum revenue. We have to plug this into here. I'm not going to do that for us. You guys can do that. I'm sure that that'll be fine. I'm going to leave it at this point. Okay. So good luck with the homework. Let me know. I know they're long problems, but you're going to have the formulas that you need to do this problem. Okay. So practice solving 2 equations, 2 unknowns. The book does not give you much harder ones than this. I have no intention of like, I need to make it much harder than the book gave you. But no, that's not happening. I'm going to pretty much pull these very similar to ones out of the book. Okay, so we're not doing stuff that you have not had a chance to practice. All right, go to your homework and I will see you tomorrow.